Whether you're joining us here in beautiful Colorado Springs or virtually, welcome, and thank you so much for joining us for today's panel titled Artemis and Industry, Building the Space Economy. I am joined by a stellar group of NASA leaders for today's discussion. We have Jim Free, Head of NASA Exploration Systems Development, Ken Bowersox, who, together with Kathy Leaders, leads the Space Operations Mission Directorate, Dr. Thomas Zurbuchen, Head of NASA Science, and Jim Reuter, Head of NASA Space Technology. Now, before we dive into our more focused Artemis topic on the space economy and industry partnerships, I'd like to provide a brief overview to ensure that our wonderful audience has all of the fundamentals. After that, I'll transition it to each of our panelists for initial remarks. So with that, let's go ahead and get started. Artemis is NASA's lunar exploration program. And it's important to understand that Artemis isn't just one mission. It's actually a series of increasingly complex missions paving the way for lunar surface missions with the first woman and the first person of color, as well as future missions to send astronauts to Mars. Artemis will turn science fiction into reality as we learn to live and work off-world. There are several key elements to the Artemis mission architecture. Artemis uses the Space Launch Systems rocket, which is the largest ever built, the Orion Crew spacecraft, a Gateway spacecraft in lunar orbit, and cutting-edge exploration ground systems and astronaut landing systems. And it's always important to talk about the why, even in an audience of people who love space as much as we all do. We're going back to the moon for scientific discovery, economic benefits, and inspiration for a new generation of explorers, the Artemis generation. In collaboration with industry, commercial, and international partners, we will establish the first long-term presence on the moon. While maintaining American leadership in exploration, we will build a global alliance and explore deep space for the benefit of all. Humanity's historic return to the moon takes flight this year with the Artemis 1 launch. Artemis 1 is an uncrewed flight test targeted for no earlier than late May, which will allow NASA to check out rocket and spacecraft systems before crew fly aboard Artemis 2. Artemis 1 uncrewed, Artemis 2 crewed, and future uncrewed lander demonstration missions with SpaceX will precede the Artemis 3 mission when astronauts will land on the moon. We'll use what we learn on and around the moon to take that next giant leap, sending astronauts to Mars. With that, I will conclude Artemis 101. I hope that you're all still awake, and turn it over to our NASA leaders, beginning with Jim Free.
Thanks, Lauren. I feel like you just gave my talk, so what Lauren said. Let's see, thank you for the opportunity to be here with my NASA colleagues, and I guess I'll just give a quick minute on Artemis 1, since that seems to be the elephant in the room. It's been tremendous to watch the team. I was at KSC till late yesterday and flew here last night, and working through a lot of issues of bringing the vehicle together for the first time, dealing with interesting commodities in large quantities like LOX and hydrogen, learning about how all these systems come together. So the test yesterday, we did get some LOX flow into the tank on the core stage, and that was all due to the team really figuring out real time what was happening on the vehicle, adjusting and getting that flowing. So we didn't get through everything we wanted, but certainly learned a great deal that we'll take into our next attempt. We will follow Axiom on the range. Pam talked about that cooperation. That's another cooperation that we have. We need to get the Axiom mission done so we can get Crew 4, and we waited for Transporter 4 to launch on Friday in order to do our test. So great, I'll say, synergies across there. There's a press conference later today with some of the folks to kind of walk through a little bit more detail, and they'll give you our possibilities. I'll address the other elephant in the room. We are working on having launch commentary. I know that's been something that folks really want, and I understand that. We're working towards that for launch. Actively working it even yesterday with our public affairs folks. Our mission is to work across all of NASA. Pam talked about that, working all 5 mission directorates. We obviously have a strong partnership with SOMD as we develop hardware and hand it over to them for operations. Our Artemis architecture is built on science to get science back. I told our congressional folks the other day, Thomas opened the last sample from Apollo a couple weeks ago, so the pressure's on us now to get some more back. And then obviously we work closely with Space Tech to integrate ourselves and use the technology that is being brought to bear. There's economic opportunities across the board from our perspective. We're about to award a suits contract that was based on services from other people using spacesuits in the future. The lander contract that Pam mentioned, that where we're developing the next set of landers that can then be a services contract where other people can use those landers for their own purposes. And we have Gateway, where we have logistics to Gateway as a service. We just put out an RFI for additional Gateway opportunities. So for me, economic opportunities are all over. Our architecture leverages private investment now and in the future, and to use those commercial capabilities for our own benefit. And then, of course, we have international partners that have their own economic opportunities that then feed what we need to do for our missions, for future elements, current and future elements. So from my perspective, we are part of the space economy and look forward to using that further in the future.
Right. Yeah. Hi, I'm Ken Bowersox from Space Operations. It's really wonderful to be here in Colorado Springs with all of you. It's neat to see how people interact here and how relationships are built that will be indispensable in building the space economy. There are a lot of ways if you want to make the space economy bigger. One way is just grow the federal budget and spend more money. Another way is to bring in private capital. It's a lot harder from a government perspective, I think, to come up with ways to bring in that private capital and expand the work that's going on. But I think it's got the biggest potential for helping us accomplish the things that we want to do in space exploration. Over the last 20 years, it's been really exciting to see the progress we've been making in low Earth orbit, trying new ways to bring in commercial partners and to develop the different capabilities that we need on the International Space Station for crew and cargo. But as I've watched those capabilities develop, the thing that struck me most is one of the hardest things for us on the government side has been to release some of the control that we had. By releasing some of the control, ceding some of that control to commercial partners that we've built trust relationships with, we can get so much more back. And I think we're going to see that trend continue into Artemis, and I think it has a lot of wonderful potential as we explore further out into the solar system.
Well, I'm really excited to be here. Jim already mentioned that, of course, science is an important part of Artemis, and we see it both as a responsibility and an opportunity. The responsibility for us to provide the information that help us pick the right landing sites with our orbital asset that has been there, Lunar Reconnaissance Orbiter. Provide the information about resources on the moon and in various regions, and therefore provide information for the technology side of the house, the operation side of the house, to really make sure our presence back at the moon becomes sustainable. The opportunity is overwhelming for us also. What we can do is with this new space economy, we can do missions, we can do work in ways, frankly, that was the stuff of dreams even 5 years ago. What I mean with that, of course, is in Artemis 3, kind of with the plan moving forward, we're working to really get the maximum science out of this. it's not the same as it was in Apollo. We have virtual reality. We have, kind of the communication system that is being built and is being deployed by Sox and his team, and the entire system that is being built with Jim and his commercial team. We're basically have the opportunity of doing amazing science. The way we treat that kind of science is like we treat any other mission, whether it's James Webb, whether it's a planetary mission, and so forth. We figure out what's the best science we can do, and we build a science and technology definition team for that, so we actually get the maximum out of it. That's opportunity. We're really excited about it. Yes, we opened that sample because, frankly, it seemed to me we believe that there's new samples coming, so let's make sure that the community is ready to really address those samples. They need to practice again, really deploy that excitement of doing this sample analysis, looking at questions that, frankly, at the Apollo time period were crazy. Questions about volatiles. Sometimes we refer to them as water. Volatiles, which, of course, we could use for fuel, perhaps, to survive, but also because of the fact that they provide enormous amounts of information about the moon itself and its history, information we didn't know was even 15 years ago. So for us, that's really exciting. Again, the opportunity, but also in this case, the responsibility, because that information is absolutely critical as we go forward and look at ISRUs and so forth. Well, we're not waiting for Artemis 3, though, to go to the moon, and we're really excited at the commercial lunar payload services. Now, everybody who has paid attention realizes that we wanted to launch some of these missions last year. I want to tell you that we struggled in a number of missions with COVID supply chain issues, but also, frankly, these are the first missions these companies are doing. We're standing right behind them, with Astrobotic, with its 11 payloads that will go to the surface of the moon, and, Intuitive Machines with another 6 payloads, and then, frankly, one in partnership with you. What has happened with the commercial lunar payload services, with the various contracts there, it created kind of an innovative flywheel that has, frankly, created an amount of innovation in planetary instrumentation and technology that we haven't seen. We haven't seen in decades. The total amount of technologies, kind of instruments that are being built on range in the order of 40. I'll talk to you about one of them. On the far side of the moon, when the sun and the Earth are on the same side of the moon, the far side of the moon is really dark and really quiet. And when Jupiter and Saturn are also on the same side of the moon, as is the sun and the Earth. So it's full moon on Earth, if you want. On the far side, it's the most radio quiet place in the solar system. So we're deploying a payload to that far side, and we're coming up with new technologies to make sure they can make measurements during the dark side there to look at the universe in ways we've never been able to do. We're doing that with the Department of Energy. That's one of many of those technologies. We couldn't have dreamt to do it. Viper, of course, the rover that will go, in mid-decade here. We're getting ready for. I just recently was there. I want you to know that every single instrument on Viper is already on a lander going to the moon before. That creates a development paradigm that's very much different than what I'm used to normally. This is the only rover I've ever worked on where the instruments are not on the critical path. That's what happens if you have a new space economy. You can start driving new development paradigms, can take more risk, create innovation platforms that are otherwise not there, and create, of course, a community that will be available for you, Sox, for you, Jim, if you need that community, and, of course, for the important technology you do, Jim. So why don't you take over?
All right. Well, thank you, Thomas. And it's a great pleasure for me to be here, especially with my esteemed colleagues and working together as we do. We in Space Tech pursue transformative technologies for both human and robotic mission enabling, and also enabling the growth of commercial space in the process. And of course, like all of us, a core element of what we're doing is to inspire the next generation. We developed this through a broad portfolio across the entire technology readiness level scale. We work for things all the way from very low early stage activities to mid-TRL, demonstrating in the lab, and all the way to flying. A core element of what we try to do is get across those valleys of death, as we talk about, and get into an infusion path. And I'll say the CLIPS and other opportunities that are there just are a tremendous resource for us. I like to say the breadth of our organization is our strength. We can, when we deploy a problem or try to solve a problem, we use our SBIRs, we use tipping point solicitations and in-house activities and stuff, and look across that and research grants across that to try to have a coordinated effort in addressing a problem. And we can do that in large part, and it results in, we have about 140 or so flight demonstrations on the books for what we're doing. And when you consider a lot of the smaller stuff we do as well, over 1,400 projects overall. And when we get to a mid to high TRL, a big push for us is to do so in a public-private partnership, because it is just a game changer of how different it is today with the space economy the way it is there is a lot of private capital that we can leverage, and we get the much stronger product as a result. One of the key ways we do that, as I mentioned, is our tipping point solicitation, and actually the preliminary proposals are due Friday. And by all indications of what we had from what we've seen so far and what we're hearing as we talk to people here is it will be far and away a record for us in terms of number of solicitations. And I can tell you it's going to be some fantastic stuff. I'm always amazed at the creativity of these. A big part of what we do is to support Artemis. Both in the human and robotic side. The solar electric propulsion system that supports the gateway power and propulsion element. A big success story actually is the rollout solar arrays that are deployed on the power and propulsion element, that also is deployed on DART and also on the ISS, among other places. That started with about a dozen SBIRs. And then through time we developed it, and it was taken over by missions as we went through. A great success story. We fly, it was mentioned by Pam, I think, that the Capstone mission, which is a small 12U CubeSat, size of a small microwave oven, and it'll be going into the near Earth, I'm stumbling over the words. So it'll be going into the gateway orbit, the near rectilinear halo orbit and stuff. And it'll be a first time to demonstrate this, in a very small package and very creative at what they're doing. On the lunar surface, we have over 30 technologies flying on the cliffs of Thomas's, doing all kinds of things for us to try to help establish a sustainable presence on the moon. And that sustainable presence means the power systems that we might deploy. How do we utilize in situ resource utilization? Are there construction activities that we can do, and so on? And how do we access areas that are extremely hard and difficult to reach? All that in concert with universities and with the industry and within our own NASA folks. There's two other things that we try to develop as we go through this consortium. One of the areas that we're trying to have in order to develop our lunar surface system into a sustainable presence, a big part of that is to engage the community as we go along. And so the reason we established the Lunar Surface Innovation Consortium is to gain a great input and coordination with and communication with the entire space community. And in the 2 years or so that we've been operating now, there's now over 600 organizations that actively participate on a regular basis. And with that, over 600 organizations that participate across all 50 states. And then just kind of to wrap up, there's a couple things we also look for. Okay, it's not just a sustainable presence on the moon, but what do we look for, and what are the tall poles in reaching and going humans to Mars? There's three key activities that we have ongoing now to do so. The first item is a deep space optical communications demonstration that's on the Psyche mission for Thomas, and we'll be demonstrating from optical communications from Mars environment and potentially from beyond. We also have what we call our lofted demonstration. It was Pam mentioned that when she talked. And what that is a hypersonic decelerator that's an inflatable. It's a public-private partnership with ULA, and we're demonstrating a 6-meter inflatable system to large heavy payloads. Ultimately, when we get to a 15-meter or so, we can land those large payloads on the moon at 20 tons or so. And then also, this is a time for us to be developing nuclear systems. Nuclear fission surface power is in our budget and is the top priority for us, but also in our budget is the early development activities for nuclear propulsion. And so it's an exciting time. I've never seen a more exciting time than right now, and it's a pleasure to be here.
Outstanding. Thank you so much for that context. See, you all did great. They were teasing me before this. We have opening remarks? Is this panel about Artemis? But you're just pulling my leg. So moving on to the questions, let's pull the thread of the space economy just a little bit further and go deeper into that. So that's kind of the focus area for this panel. But for a lot of us, I think the concept of a space economy is still relatively new and perhaps not specifically defined. So what does the space economy mean to you, and why is Artemis key to building it? Jim, would you start?
Sure. So the example, nearest term example for me is the commercial LEO destinations, not to steal from Ken here, but that's key to us. We have things risk we're buying down on space station today. When space station reaches the end of life, we'll continue to use the commercial LEO destinations, which to me is a great example of the space economy, to do our buy down of risk for lunar and Mars missions, to take advantage of that microgravity where we can cycle payloads up and down very quickly. So for me, I look at that's our first opportunity. The other is, as the space economy, I think Pam talked about it, about folks early in their career, about the opportunities. Many of you here that bring those opportunities. We have that to benefit from as we develop our architecture to go to Mars. So we'll keep our architecture open as technologies develop in other parts of the space economy that can then improve our reliability, our safety, or our mission duration for our Mars missions. So to me, I look at those two examples.
Excellent.
I mean, to me, the space economy is just the production of goods and services in space. For all different kinds of reasons, for amusement, to scientific knowledge, to go further than we've ever gone before. And I think there are lots of ways that we can develop it, but the best way is to bring in more and more participants and watch more and more missions start to proliferate, both government missions and non-government missions.
And for me, the way it becomes part of our life and kind of the Science Mission Directorate, one of the things I really want us to do is continually ask, what are the opportunity spaces that are there? So we focus tunnel vision on new science and science per dollar, and we use the tools that are there so we can in fact become first customers in some of these new places, or we can take advantage of opportunities that frankly were not there to do amazing science. And so for me, even if the government assets, the space station, together with our international partners, you really taught us, I believe, and kind of taught the science community. The science community was very much used to building their own stuff all by themselves. Like what happens, frankly, on the space station, you have more payloads than we can accommodate. We have an embarrassment of, I call that a good problem, because people, especially for those out there who want to build commercial space stations, right? Well, we have instruments that want to sit on the outside of these. We have science that we want to do on the inside of these. So look through the lens of what is the science opportunity and how can we be customers. We don't want to own these companies. So we kind of always say, if somebody uses the word commercial and I'm 80% of the market, not so interested. Because my worry is I will squeeze all the commercial spirit out of them by the time we're done with the contract. But what I'd like us to do is really be a customer and kind of stand and learn how we can create opportunity spaces that otherwise were not there. So that's how I see it. It's in an ever-evolving field of opportunity.
And what I'd say is the space economy right now is defined by the consumption of resources for the betterment and use of space is a $400 billion industry right now, and it's on the way targeting towards $1 trillion. And I suspect it'll get here faster than we think. And for us, as I said, that really equates to now it's not just the venture capitalists that are highly, that are geeks for space. It's also much more conventional people who are looking for opportunities. And yes, space is exciting, so it draws a lot of extra, but it's a lot more opportunities for investment into capital investment. And that leads us to being able to take advantage of that and utilize this. And those that community is obviously low Earth orbit, suborbital orbit, geo and stuff is obviously a mainstay right now, but it also there's a strong push towards cislunar space and the utilization of that from an economy standpoint. And so we're seeing a lot of investment that we can really take advantage of.
So as we move, I guess, into this space economy that's continuing to develop and grow, we know that we need vision, we need talent, but we also need resources. So can you help us understand, and from your perspective, how the recently released NASA budget supports Artemis and the goals that we have?
You want me to start?
You offered.
All right. So the budget supports us with our SLS and Orion vehicles that we need. That's our building block. It supports us getting to Artemis 3. Which includes the development of the lander and the suits. It supports us starting this next lander procurement. What I think we NASA need to continue to focus on is where can we maximize those dollars in the budget to get to go after things that other folks have already developed, and where can we do better in how we perform on our program and project work. I talked at the beginning about the relationship between exploration systems development and space operations. Our vision is to hand over programs to space operations when they finish development, and each one looks a little bit different. But how we do that is intended to free up dollars to come back and start the next development. If we don't do that, then the budget that request is there today and in the future is not of value. That's why these mission directorates were set up, and that's completely our job. So I think the budget is there to support us through 3, start this new lander development, help us get Gateway up there, get that infrastructure to start the science.
You mentioned vision, talent, and resources. In space ops, we have resources to do lots of great things with commercial LEO platforms, continuing our commercial crew and cargo capabilities for the International Space Station, maintain the International Space Station, do new activities there, and set up some new commercial approach to procuring communication services. So there's a lot in the budget that we're allowed to do. The vision part, I think, is harder for us to try and exactly see where we're going and what we need to do, and to stay out of the way as our commercial partners come up with new ways of doing business. Is tougher. The other thing that's tough is having sort of a unified regulatory framework, because developing the space economy is in NASA's interest. We have taken on a lot ourselves, where we try to facilitate the growth of different commercial entities and enable them to get their job done. But at some point, that's not really NASA's job. That needs to move out and into other parts of the government. And we're already seeing discussions there. And that's one way you'll know the economy is growing, is work that NASA's doing now will move to Commerce and the FAA, and we're seeing it start, and we'll see more of it.
And from the talent side, there's a number of companies that tell us how they're having a hard time holding on to their talent because the companies are growing in their neighborhood. And I always thought, what an amazing thing if you're an entrant into this industry, because people are chasing you around town. And I'm like, that's an amazing thing. It's kind of, I see people that I used to teach, used to be in my classroom 10 plus years ago, and they're in these leadership positions in companies, they're in these leadership positions within the agency, frankly, and many of the projects. That half the shifts of the James Webb Space Telescope at night, the night shifts were run by one of my former students as the shift lead. And so I'm just tremendously proud of both what they're achieving, this kind of generation that's behind us, and I consider it our job as we're opening up that opportunity space, both the commercial one, but also from the talent perspective, to really help that talent pipeline. But I'm also just in awe about the opportunities of the ones that are just, coming out of schools now, and kind of the opportunities that they have going forward, including some of these skill sets such as welding and kind of manufacturing that are so needed in so many of these industries.
Absolutely.
And what I'd say is, first of all, the space tech budget for FY23 we're pleased with. It's enough for us. It maybe isn't everything we'd like to do, but it never is. And it's enough to allow us to really look at and maintain a very broad portfolio portfolio as I talked about sooner. A key part of this, I think, is to really, how do we operate with the community to ensure innovativeness and creativity as we're going along? And and the more we do things where we kind of leave open this trade space and have an open thought of how we do of what they might accomplish. The CLIPS is a great example of that, and the payloads that are there as well. And wherever we give something we're not quite as prescriptive, creative things happen.
Excellent. So we talked a little bit about how there are so many opportunities now, which, I mean, as a young professional myself, I definitely see that. I've got friends that are kind of have all these opportunities when they graduate, which is a fantastic place for us to be, I think, as an industry. But there are some out here, perhaps future industry partners that are not involved in Artemis right now. They want to be part of it. So what tactical steps can they take to join this whole mission for Artemis? And I think, and Jim, I'll start with you because I think you mentioned some of that just a little bit in your opening remarks.
Okay, sure. What I would say is probably the first way that you need in order to get engaged, is to have a really good idea, or have something that you address a need that's out there. And you have a prospect for going to get it. Then we have a lot of solicitations across the board here with that NASA, where some of those ideas can be brought out. For us, if you're a small business, a great place to start is Small Business Innovative Research, because there's several hundred small contracts that we have for a year to check it out, along with a lot of other solicitations. And I mentioned the tipping point that it's going now. And then beyond that, we have ways to communicate with the community. I mentioned the Lunar Surface Consortium that we have formed. That's a great place that on a monthly basis you can see what's going on. Johns Hopkins APL is the lead for that, and so you can readily find your way to that through their website, and so there's a lot of interaction and exchange. We also, from our standpoint, have developed a strategic technology framework, and with that framework we've identified the outcomes that we're trying to achieve, and then the capabilities that we need to have in order to achieve that. And those are things that we've developed now through our principal technologists, how to put those things into where is our desired future to be. And our intent is here in the next couple months, every couple months, is to release in 4 sets these activities, so we get feedback from the community. Hopefully it's a two-way thing, so you can see better of what we're thinking from a technology standpoint, and also help guide us. And so I think there's a very broad spectrum, but start with your good idea and start working it.
Excellent. Any other ideas, thoughts on how we can get involved? We've got excited people out here in the audience that want to join in Artemis.
I would say our architecture team for a number of years now has done some, I'll say, forward-leaning engagements with industry across the board, big to small. Where we understand where those entities are going with the work they'd like to pursue, understand how it helps the overall architecture that we have, and figure out where are those opportunities that we can utilize that technology, and work with Jim to figure out calls that can elicit the things we're trying to buy down in our architecture. So that's been led by Greg Chavers and Doug Craig. I know they're here, they're involved. I think reaching out to them, being proactive. I know that they have a couple industry interactions every year. I know we're thinking about having one this summer. That's the way to understand. Here's what company X wants to pursue. How can we help further that? How can we utilize that? Much like we do with our critical international partners too.
Yeah. I think to get involved, the most important thing is a passion for the work, and then some great creative ideas. It's been fun to watch the small companies get involved, just like the big companies. In our contracting efforts, we've got requirements that big companies have to include small companies. So I wouldn't let that deter me if I was, just a graduate student right now with a neat idea. I wouldn't let the fact that I'm a one-person company frighten me away from doing the business, because if you've got the passion and you've got the ideas, you can find a way to get built into the system and become part of what we do in low Earth orbit and what we'll do beyond low Earth orbit.
Excellent. So I have a question from the audience now. We're going to transition to some of your questions. Thanks for sending them. And this one's for you, Dr. Z. What are the key science objectives that you want to achieve on the lunar surface beyond 2024?
That's Zurbuchen's because it's got science in it.
That's right. Look, I think the core objective, and by the way, I'm talking about both what I'm hearing from the national academies. You should know next week I will get the strategy, the planetary strategy from the national academies. I asked for that not because I don't know how to make decisions, but I'm not good in most science. So I'm just good in very little science. So basically trading science against science, I really want another body that is smarter than me to make this. And so you should know that decadal that we're going to get actually has as a task the integration or into Artemis directly. So I just want to tell everybody, even though what I'm going to tell you is what my belief is today, next week I'm getting really important guidance. The highest priority is really focused on resources and volatiles, both because of the science, that kind of water cycle on the surface of Mars, surface of Moon. There's one on Mars too, but surface on the Moon is really critical. I think the other thing is really if you want understanding the history of the Earth system, and we actually think that dating the Earth, the best way of doing that is at the Moon. We have specific areas you want to go take measurements that really take kind of ambiguities in our kind of chronology off the table. Of course, the history of the Moon is our history, so there's important science for that. And I think the third piece is really utilizing the Moon and its environment as to do measurements that otherwise are not possible. I want to refer back to the Lucy instrument I already described that uses the radio quiet regions. So those are the three that I would focus on.
Thank you. So another question from our audience. With international collaboration in missions such as James Webb Space Telescope and other successful stories of us all coming together around important missions, do you see European space partners and more global space partners also embracing and shaping that commercial space economy?
Yeah, I guess I'll start. Those international partners I mentioned earlier are absolutely critical to us. And the agencies that we partner with have an industry that they rely on to build that hardware. And I would expect that innovation, I think I wrote it down, Thomas, the innovative flywheel that you mentioned earlier. Every time I listen to Thomas, I learn something. Is spinning just as well in those other countries. And seeing the way the space economy has taken off, I would expect that commercial, and I think you're seeing it now, that commercial to roll out of that effort as well.
So one of the things that I want to talk about that I think it's just that there's a lot of learning ahead of us. There's a lot of learning ahead of us, and I certainly didn't want to give the impression that I figured it out. I don't want to speak for my colleagues. Let me give you one of the examples. It's really clear that the entrepreneurial ecosystem, just if you look at just sheer amount of venture capital kind of expended in the United States by far eclipses what happens elsewhere. So what that does, it creates kind of tension. So we have, of course, our international partners are dear to us, and we love working with them on the missions. 2/3 of science missions have international partnership. All of the core kind of elements that we're doing have them, and we think that makes us stronger. But what we need to figure out now is how do we make sure that, in fact, the industries in these other partnerships, wherever they are, whether in Europe, in Japan, whether they're elsewhere, that they too kind of find support without really, if you want, taking energy out of the commercial ecosystem. I'll give you an example, just so you know what I'm talking about. We could be working with every international partner and creating agreements to fly their instruments to the Moon using commercial lunar payload services. I think that would be a horrific mistake. Because what I just do is I destroy part of the market for the commercial lunar payload services. The kind of a market with less friction is one where over time the commercial, our international partners say, hey, I'm going to work with this company, and go work with them directly. So how we get from where we are today, we're perfectly excited to have these discussions, but how do we get to this world that's much more seamless and kind of without boundary, kind of like the commercial entities are, is something we're still learning.
Excellent. So as we kind of, I guess, reset, to tie a bow on this conversation, we started with talking a little bit about what Artemis really is, what Artemis means, and we've detailed some really important pieces of the partnerships, the talent, all the resources. But what I want to challenge us to do, just to kind of close out our panel, is to fast forward a few decades and look to the future. So if Artemis, as we understand it today, all goes as planned, what do you think the space economy looks like maybe 20 years from now?
I guess I'll go first, and I'll improve on any answer I come up with. I think I see it evolving much like low Earth orbit has. Our access to low Earth orbit, to space station, is now a service. I would expect us to have built the sustainability that Pam talked about on the lunar surface that allows us to access the lunar surface in a commercial way as well. Our job at NASA is to not hold on to things. Many folks say, why are we doing services for landers? Because we don't want to own that forever. We want to use that as a service so that we're pushing the next boundary. So in 20 years, I'm hopeful that there is some kind of infrastructure on the lunar surface that is available to commercial entities, that is used by commercial entities, that we still use, but not as the sole owner, and we are pushing on our way to Mars. If that's the case, then there's an economy there that we have been a part of creating.
Yeah. It's always fraught with peril to try and predict the future, but what I see is like Jim said, what we've got going on in LEO right now will move out to cislunar space. And we'll see private missions that go to the lunar surface. I think we'll see some people that go there for private science reasons or to explore for resources. We'll see missions that aren't driven by government requirements, but they're driven by private requirements. And at some point, 20 years is probably a little too soon, but at some point we're going to see exploration missions that are driven by corporations on Earth rather than by the government.
Yeah, and I think there's important transitions that are really hard to predict, but are already at the horizon now. The availability of big large launch systems, whether it's the one that you talked about at the beginning, some of the commercial options, fundamentally change how we do things. Standing in front of the Ariane 5 with the James Webb Space Telescope on it, $10 billion of investment, I don't wish that on another person necessarily. I mean, the Ariane 5 team did such an amazing job, but the question is, how do we kind of transfer, a future kind of in this environment? How do we create solutions for advanced telescopes, for Earth observing systems that really use these kind of tool sets that we've talked about? To me, I think a significant fraction of science will move in that space. And our job is, of course, as an agency, is to first both utilize that, but also focus on the leading edge and trying to make sure that we build, I hope 20 years from now, a spacecraft that goes to other stars, right? And I mean, of course we need to do that. We have nuclear systems that are really providing power in many places, and also propulsion in area kind of orders of magnitude above what we currently have. And so it's these things that we should be focused on.
Yeah, and what I'd say is, first of all, I hope there's a rough parallel with the airline industry, that we start seeing that, especially in the places where it's more natural, and in the cislunar space and low Earth orbit and stuff. And we see that there's some technology advancements we can still engage in, like we do with ARMD, with our research organization in aeronautics. But that largely it's a service thing. And we set our attention on the next great thing. And I don't think in 20 or 40 years we're going to run out of next great things. But we'll go further and further in our exploration. We'll leave this solar system and we'll go beyond.
Outstanding. All right, so I'm going to bring us back from the future. We're here today in Colorado Springs, or if you're online with us virtually. So I want to thank you, all of our distinguished panelists, for the wonderful discussion. I think the future is bright in space, and Artemis just shines so brightly. Thank you all for joining us, and hope you have a wonderful rest of your space symposium. Thank you.
Yeah, Lauren.